All right, let's take a look at the day 2 homework over solving trig equations. So again, I'm just going to show you these answers, kind of point out some common mistakes and issues that I see people have. So some of these equations were a little harder, but again, we were only trying to find answers within one complete revolution of like a unit circle. So number 1, I subtracted the 3 over, got negative 1 divided by 2, so negative 1/2. I went to my chart, sign is negative in quadrants 3 and 4, so I got those two angles and then I was done. That's all there was to do on that one. Number 2, a lot of people have trouble with number 2. The first step is to get rid of this positive 1 by subtracting by 1. So you take 1/2, you're going to subtract 1 from 1/2. That's going to give you a negative 1/2. But you've also got that negative sign that's in front of the cosine as well. So think of this as a negative 1 that is multiplying the cosine. So you'll want to divide everything by negative 1, so this is now positive 1. So if you look at my answers are from quadrants 1 and 4 because it was a positive 1/2 that I had instead of the negative 1/2 from up here. Number 3, sorry, I divided by 4, which gave me 1/4. Now, that's not anything on our chart, but watch the next step. The next step is to take the square root of both sides. Well, the square root of 1/4 is 1/2. Think of it, the square root of 4 is 2, so the square root of 1/4 would be 1/2, but it's positive and negative 1/2. So not only is 1/2 on our chart, but because I want positive and negative, I want all 4 angles that have a cosine value of 1/2, both positive and negative. And so that one had 4 answers. Number 4 and 5 are pretty similar to that. Those both involve squares. And when you take the square root, you just have to remember to have the positive and negative on both of those. So those are both going to generate 4 answers when you solve those. Same with number 6. Move the 3 over. It's now a positive 3. Divide by 4, but then take the square root. The square root of 3/4 would be the square root of 3 over the square root of 4, which is 2. So again, whenever you do this, you should end up with something that's on our chart. And if not, that's kind of a clue to you that you did some kind of mathematical error in solving the equation. And again, that one has those 4 answers. 7 and 8. 8's pretty straightforward. Again, for the notes, I would have added pi here. For this, I added 2 pi. I'm sorry if that's a confusion, but what's going to happen is, regardless of what this is, so if I wrote this as plus pi k, again, that is going to get multiplied by that 2 and become 2 pi k. So whatever angle I end up with, which in this case is 2 pi over 3, adding 2 pi is going to give you an angle that's bigger than what we want. So this one only has one solution. Number 9. I took the inverse cosine of negative 1/2, which gave me these 2 angles. I divided everything by 2, which now gave me these 2 angles, and also changed my 2 pi into 1 pi. So there are going to be extra answers that I need to get, not just these 2. This angle plus pi and this angle plus pi will still give me answers that are less than 2 pi. And then the bottom was just plugging this into your calculator and understanding this is the answer my calculator knows. This is the principal value that my calculator knows. There's another angle in quadrant 2 that has a sine value of 0.4 as well. And so I took this angle, I subtracted it from pi, and that gave me this angle. For number 11, I did the inverse tangent of 5, and I got 1.37. 1.37 is an angle in quadrant 1. And this is 1.37 radians. But there's another angle over here in quadrant 3 where tangent's also positive that's also going to have a tangent value of 5. And that would still have that same 1.37 reference angle, but it's 1.37 away from pi, 3.14. And so I took 3.14 and 1.37 and added them together, and I got 4.51. Same with 12. I took the inverse cosine of negative 0.9, so that is an angle in quadrant 2. That's where cosine's negative. That's the principal value that my calculator understands, 2.69. But there's another angle over here that has that same reference angle, so you need to figure out how far away is this angle from pi, 3.14, and whatever that difference is, you need to add that to 3.14, and that's where you're going to get this second angle. This isn't an extremely important thing for this chapter. In fact, when we take the test over this, it will be a no calculator test, so these kind of problems won't be on there. But this is important to understand, and especially number 10, this is something that's going to that we're going to have to understand how it works when we move into chapter 8. We're going to be working with some triangles, and this little second angle thing is going to pop up on us. So just wanted to kind of introduce it here. Again, if you have any questions, send me a Schoology message, and I can try to explain that.